So I go to make my lunch this morning, take out the bread, mayo, all the stuff, start going to find the cheese, and sure enough, there's no ham. So I finished the ham. Nobody told me that they'd finished the ham, so there I am with a cheese sandwich instead of my ham and cheese sandwich. What's the limiting reactant? You guessed it, it's the ham. So that's what we're looking at today with this number 10 on the limiting reactant practice. Okay, we got to figure out what is running out first, and that's what's controlling the whole reaction to this thing. So when we look at number 10, it says an unbalanced chemical equation is given as that. If you have 100 grams of sodium, 60 grams of oxygen, we got to find the number of moles of sodium oxide produced. Well, first thing we got to do is balance this thing out. I've got sodium on the left and I got sodium on the right, and this is kind of the trap. We got to be careful with this one because if you look at the oxygens, I got 2 on the left and only 1 on the right. So that means I'm going to have to put a 2 here and see what happened. We changed the sodium to 4. So 2 times 2 giving me 4. Now over here on this side, I've got a sodium by itself. So this is always nice because I can multiply by anything. And in this case, I'm just going to put a 4 on there. That means oxygen is going to be a 1. All right, cool. We've got our coefficients. Now we're going to look at this thing, and it says we've got 100 grams and 60 grams. These are my 2 starting lines. If you have 2 starting lines, you know you have to do 2-dimensional analysis because it's a limiting reactant problem. So we're going to call this one A1, and we're going to call this one A2. And both of these, we're only making one product, so I've only got 1B, which is the sodium oxide, okay? And that's going to be this one over here on the right. This one's going to be my A1, and this one's going to be my A2. All right, so keep an eye on the colors. I'm going to try and maintain that throughout this video. All right, so we know we got to do 2 charts. Let's go ahead and get started. But if you notice, it said moles. Okay, so we don't have to go all the way to grams yet. We can just go ahead and stop at moles on this one. So happy dance, because that just means it's only 2 steps. Okay, so we're going to do this. We'll start off with A1. Now, if I have 100 grams of A, down at the bottom, grams of A. Up at the top, mole of A. Down at the bottom, mole A. And up at the top, mole B. If you're still having trouble with this, go ahead and watch the first video. This one's going to focus more on the limiting. All right, now we're just going to plug and chug. Time to put in some numbers. We know that it is grams per 1 mole. And to do the mole-to-mole ratio, we're going to look at the coefficients. So I look in front of mole A, which is sodium, and I find a 4. I look in front of mole B, and I find a 2. So I just plug that in there. Piece of cake. The only thing we have missing now is going to be grams per mole. We get the grams from the periodic table. So I know that this is sodium. Sodium's atomic mass is 23. And there you go. Go ahead and pause it, plug it into the calculator, see what you get. Welcome back. Does it match my answer? So we ended up making 2.17 moles of sodium oxide if we have 100 grams of sodium. But it tells me we also have 60 grams of oxygen, and now we got to be careful because we don't know which one's going to run out first. Which one's going to be the ham? Okay. So I've got grams of A at the bottom, mole of A up at the top, mole of A2 on the bottom, and then we're going to do moles of B at the top. We know what the moles of B are. That's a 2. You can look right above at the other one. We know that this is going to be a 1 because it's grams per 1 mole, always. Now we got to look at the coefficient in front of oxygen. It's only a 1. Yay. And so now I just got to figure out what is the molar mass of oxygen. Remember, gens are diatomics. So this is going to be 32 because there are 2 oxygens. So there you have it. Everything's plugged in. Now all we have to do is put it in the calculator. Go ahead and pause it. You can come back, check to see if your answer matches mine. Welcome back. I got 3.75 moles of B. Now this is where we have to stop and think about what happened here. I have 100 grams of A1. I have 60 grams of A2. The least amount of product. Okay, so remember this is the product that we're making. Okay, and so this is essentially the answer for A because the most amount of product that I can make is the smaller amount, because the 100 grams of A1, or in this case sodium, is the ham. This is going to run out. I can't make a sandwich, okay? Or I can only make 2.17 sandwiches. All right, but when it asks for limiting reactant, this one didn't ask for it, but you're going to see it, and so I want to just take a minute to review it. The reactant is something different. That's this. That's the 100 grams of A1. That's the sodium. Therefore, sodium is the limiting reactant, okay? Because it can only make 2.17 moles of product. So that means this one's not even real. This doesn't exist. Kind of like my lunch. You know, I don't have a ham and cheese sandwich. I got a cheese sandwich. Great. So let's get rid of this thing. Okay, now the next question, part B, is saying find the mass of excess reactant left over. All right, so don't freak out, because now basically we're going to have to do a third one, but you have all the information. It's just plugging it in. Okay, so we're going to have to make a third one, and it's asking for the mass. So that means we're going to have to go in grams. This is going to have the full 3 steps. We're going gram to gram. Okay. But instead of going to be the only product, we got to figure out how much oxygen is being used up. You see that over here? So we need to figure out how much of oxygen we need. So now my A2 becomes my new B. And I got to convert from sodium to oxygen to see how much oxygen is going to be used up dependent on the 100 grams of sodium. What happened to the 100 grams of sodium? It's gone. Got used up. No more ham. Okay. So how much cheese do I have left over? Let's take a look. Start it all the same way. 100 grams of A1 on the top. If you notice, we already have this done. So we can just copy this down right in here. And it's going to be mole A over grams of A. It's 1 over 23. We know the coefficient here is going to be 4. This part doesn't change. So we can just copy it from right there, right above. Now, the only thing we got to change is the B. And we already had the oxygen stuff from the last one. Hopefully you can just look at it there on your paper. And we know that the coefficient in front of mole B is a 1. Mole B at the bottom is also going to be a 1, because we're going to grams of B. And the grams of B was 2 oxygens, 32. All right. See, that wasn't too hard. Now it's just putting it in the calculator. You plug it in, and this tells me 34.7. I'm just going to round it up to 35. Make the math a little easier. And this is how much of the reactant is left over. It's asking us for how much of the reactant is left over. The 35 grams is how much of the reactant we used up. Okay, so that means that I got to take the 60 grams that I originally had. I know that I used up 35 grams, and I know most of you are thinking it. We're going to subtract. We got to take the 60 grams that we had minus the 35 that we're going to use as calculated by the limiting reactant, and that means we finish with 25 grams of O2 in excess. And that's your answer for B. All right, guys, post if you have any questions. You can pause, rewind this problem. This one works for all of the ones that are limiting. The only time you have to do the third step, the red one that we just did, is if it says find the mass of the excess reactant. Some of the other ones only said find the limiting. If it finds the limiting, you only have to do 2. Have a good day.